In this video, we're going to begin our discussion with solving quadratic equations. A quadratic equation is an equation of the form ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0. Now, if a did equal 0, then this first term here would be 0, and I would be left with bx plus c is equal to 0. No longer do I have a quadratic equation, that would be a linear equation. All right, so I've written a couple of examples of quadratic equations. So a polynomial equation is an equation that can be written as p of x is equal to 0, or p of x is a polynomial. And I've written some examples of polynomial equations. So every quadratic equation is also a polynomial equation. All right, so before we talk about solving quadratic and polynomial equations, let's answer the following questions. What's 0 times 4? Yeah, of course, it's 0. 3 times 0, yeah, 0 again. And 0 times 0 is 0. So, when I can multiply two numbers together to get 0, what do you notice about the factors? Well, at least one of the factors has to be 0, if not both. Well, this is what is referred to as a zero product property. So if a and b are real numbers, and a times b is equal to 0, then a is equal to 0, or b is equal to 0. All right, so let's solve the following equations. So the first example is telling me, because it's set equal to 0, I can set each factor equal to 0. Well, 2 equal to 0 doesn't make sense, and if I plug in 2 for x, I get 2 times negative 6 times 2, and that does not equal 0. Solving the other equations, I get 8 4/3. So I can rewrite that in solution notation here. And again, you can check each of the values. If I plug in 8, it's 2 times 0 times 20, which is 0. And then I'd have 2 times a number times 0, which is also 0. Okay, let's do the next example. So because it's set equal to 0, I can set each factor equal to 0 also. This is x equal to 0 is already solved, and this is 10. Plugging in 0, that's 0 times negative 10, that's 0. If I plug in 10 to the original equation, it would be 10 times 0, that's 0. Okay, so now that we've talked about the zero product property, let's talk about how to solve a quadratic or a polynomial equation by factoring. First off, we want to set the equation equal to 0. Factor completely. Set each factor that contains a variable equal to 0. Solve each of those equations, and then check your answer. Okay, so let's solve the following equations by factoring. So again, the first thing I want to do is I want to move this term over to the left-hand side. So I'm going to add 63. And remember, I want to set it equal to 0, so eventually I can use that zero product property. Okay, so let's factor. So remember, we check to see if there's a greatest common factor. The only GCF we have here is 1. So again, I want factors of 63. Whose sum is negative 16. The two factors that work here is negative 9 and negative 7, because negative 9 plus a negative 7 is negative 16. So I break down x squared as x times x, so minus 9 and minus 7. Set each factor that contains a variable equal to 0. And we get 9 and 7. So the solution set here is 7 and 9. And you can go back on your own to verify that 7 is a solution to this equation and 9 is a solution to this equation also. Okay, let's take a look at the next example then. So again, first thing I want to do is to set this equation equal to 0. So I'm going to subtract the 27. Why? So the first thing I want to check here, is there a greatest common factor I can take out of all the terms other than 1? In this case, I can factor out or divide out a 3y. When I do that, that leaves me with 4y squared minus 9. Now, take a look inside the parentheses. There's 4 terms. So the first thing I'll check is, are each of these terms perfect square roots? In this case, they are, so I could use the difference of 2 squares. So bring down the greatest common factor. Square root of 4y squared, that's 2y. I'll write 2y and 2y. Square root of 9 is 3. Remember, with a difference of 2 squares, one is negative, the other one is positive. So, set each factor that contains a variable equal to 0. So I'll do that over here. Solve each equation. And again, you can verify all 3 of these solutions, but I'll write them like this. So we're done here. Okay, so let's take a look at the next example then. So again, first question, is there a greatest common factor I can take out of all of the terms other than 1? In this case, there isn't. Now, I have 4 terms on the left-hand side. So the only factoring technique we've talked about with 4 terms is factor by grouping. So I'm going to group the first 2 terms together, and I will group the second 2 terms together. Okay, greatest common factor from the first 2 terms is x squared. So when I factor out or divide out x squared, I'm left with x minus 4. Now, second set. Because the first term here is negative, I'm automatically going to factor out a negative, so it matches up in the parentheses. But I can also factor out a 4. So when I factor out or divide out a negative 4 from each of these terms, I'm left with x minus 4. Okay, both of the parentheses are x minus 4, so I can factor again. Now, can I factor further? Well, the x minus 4 I can't. X squared minus 4, though, they're both perfect square roots with subtraction in between, not to mention it's 2 terms, so I can do difference of squares there. So I'll rewrite the x minus 4. Square root of x squared is x and x. Square root of 4 is 2. Remember, with a difference of 2 squares, one is negative, the other one is positive. Set each factor that contains a variable equal to 0. So here I get 4, 2, and negative 2.